In this video, we'll be making a project of monitoring real-time census data over internet with the help of augmented reality. So yeah, this is yet another episode from AR with IoT series, and in this series, we already made some cool projects like controlling the home appliances with the help of the touchscreen button, as well as with the help of AR like the virtual button. And we successfully made that project. And in this video, we are taking this particular AR with IoT a step ahead and really monitoring the census data in real time over internet using augmented reality with the help of the Unity and Blynk IoT platform. Let's get started. This video is sponsored by LTM, which is a PCB designer software company. LTM has all the tools that you need to design a professional PCB with high productivity. And well, it is widely used in big electronic companies like Texas Instruments, Siemens, Seagate, and many more for their PCB designs. It has advanced routing features, real-time cost estimations, and also you can design your own flexible PCBs using this software. So this is an all-in-one professional PCB designing software for all your needs. So go ahead and try your hands on with this software. A free trial version is waiting for you. Now click on the link mentioned in the description to get a free trial of LTM Designer software. So let's start with monitoring the census data using AR. For that, just open up Unity and click on New Project. Now give this project a name. I will name it as AR Sensor. That will be good for me. Click on Create. Now it will take some time to create the project, and in the meantime, we need to download the Vuforia engine package. For that, you just need to go to this Vuforia website, and after doing that, just log into your account, and after that, just click on Downloads. After going to download, you just need to add this Vuforia engine project. You just need to click here and it will automatically download this file. Click on I agree. And that's it. It started downloading already. So yeah, our Unity file is successfully created, and now the first and foremost thing we need to do is we need to install that Vuforia package that we just downloaded. Okay, so let's just move back to the web browser, and it's still downloading. Let's just wait for a couple of seconds. Okay, so the package is successfully downloaded. We just need to double click on this package. It will automatically redirect us to our Unity project, and we just need to click on import button. Okay, so the Vuforia package is successfully added, and to cross check that, you just need to right click here, and as you can see, the Vuforia engine option appeared here. Let's just add the AR camera because we'll be working totally in augmented reality. So as we've added this AR camera, we don't need this main camera, so we'll simply delete this. After adding AR camera, just right click on this particular option and go to Vuforia engine again and select image target. Okay, so first of all, we need to finalize our target image, and in our case we already finalized it. Let me show you that image. So yeah, here is that image which will be used as a target image, and on which all the AR things will be happening. Don't worry, I'll be providing this particular image in the description, so you can click the link and download this image. Okay, so after finalizing the image, you first need to create the database of it, and for that, again, go to the Vuforia website, and here you need to click on the develop button. After clicking on develop button, just go to target manager and click on add database. Give database a name. I will name it as AR Sense. The device name should not have space, so I will remove the space and AR Sense. Okay, click on create. After that, just go to that AR Sense option, and here click on add target. Click on browse, and here choose the file that you have selected as a target image. Click on upload. After that, just provide the width as 1, name will be test, that doesn't matter. Click on add. After that, just checkmark this box and click on download database. Select Unity editor and click on download. After downloading, just double click on that downloaded file. It will automatically redirect you to the Unity project, and you just need to click on the import button. Now the next step is to add the license, and for that, again, go to the Vuforia website, and here click on license manager. Click on get development key. Now give it a name. I'll name it as AR Sense. Checkmark this box and click on confirm. That's it. Just click on this AR Sense and click here to copy the license. Now go back to your Unity project. Click on AR camera. Click on open Vuforia engine configuration and just paste that license here. And after that, just click on add license. So with this, we have successfully added the license, and now we need to add the target image. And for that, just go back to your Unity project. Click on image target. here select the type as from database, and the database will already automatically appear here, which is AR sense, and the test target image is test. And I double click on this image target. As you can see, here is our target image that we have selected for our project. Okay, yeah, this is the image. And now let's just start adding that AR components on it. But before that, let's just make this target image size a bit bigger so that it will be very easy to add the components on it. Okay, I'll scale it to 50/50/50. Don't worry, in the end we'll be changing back to 111 to its original size. Okay, so after doing that resizing part, just right click on this image target, go to 3D object and click on a plane. So with this, we have successfully added a plane on it. Now we'll be providing an image to this plane, and that image I already prepared. Let me just show you that image. So yeah, here is the image. You can see the template image. Now here we'll be displaying the temperature data, and here we'll be displaying the humidity data. Okay, so that's why I prepared this particular template. I'll be providing this image as well in the description, so don't worry. So what I'll do, I'll add this image inside my Unity project. So I'll drag and drop it here. Great. So now what I'll do, I'll just drag and drop this VR frame inside the plane. Okay, and the image is successfully added. Now it is rotated, so I will change its orientation. Perfect. Okay, so now what we need to do, we need to have something to display the sensor's value, and for that what we'll doing, we'll be adding the input field here. For that, just right click on the plane, go to UI and click input field. Now it will create a canvas for that, and on that canvas that input field component will appear. Okay, so as you can see, this is the canvas and this is the input field. Great. Okay, so now what I'll do, to change the orientation and the size of the canvas, first we need to change its render mode to world space. For that, just click on the canvas, click on render mode and select world space here, and provide the camera as AR camera. Great. After doing that, now we'll be able to change the orientation and size. So first of all, I'll change its orientation. So I will click on the canvas and change its rotation to 90 degree. Perfect. Now I'll change the angle to the top angle, and now I will resize this canvas quickly as the size of the plane. Okay. Okay, perfect. Now what I'll do, I'll select this input field and arrange it under the temperature section. Okay. And similarly, I'll add one more input field here and arrange it under the humidity section. Perfect. Now I'll change the size of this particular boxes. For that, select input field, click on this icon, and I will make this a bit bigger. Similarly for this box. Great. Now as both input field boxes will be displaying different data, I will change the name of it. So for that, I will select input field here and change its name to input field temp. Select this input field and change its name to input field hum. Okay, and I'll increase the text size a bit to display the data in much readable manner. For that, just click on this arrow, click on text and change the text size to 80. Similarly do for this particular thing. Perfect. Now one thing here which is very odd is here the text box is white and the background is a bluish color. So let's just change the text box size to blue as well. For that, click on this particular input field, select color, click on this color picker and pick the background color. Now it looks much more neat. Okay, similarly doing for this particular thing, click here and check mark. Great. So now everything looks pretty nice onto this particular plane. Now what I'll do is I will resize this whole plane in the size of the actual target image. Okay, so I'll quickly do that. Now one thing we missed here is we want the data to be displayed like perpendicular to the image target, and for that we need to change the orientation of the plane. So just click on the plane and change its rotation to 90 degree. Okay, now it is perpendicular. Now I'll just rearrange this to display in just front of the plane. Okay, perfect. Now the last step is we need to add a virtual button. So first of all, why we need a virtual button? See, what happens is the data will be displayed onto the template only when we are pressing that virtual button or any random button. Okay, so as soon as that button is pressed, a link will be requested to the server and we'll be getting a new data. Okay, so every time we press the button, a new data will be called and will be displayed onto this particular chart. Okay, so for that reason we need to add the virtual button, and for that, like for adding the virtual button, just click on this image target, click on advanced and click on add virtual button. double tap on the virtual button. Now as we need to add an image to this virtual button, I will add a plane over it. For that, just right click on this virtual button, go to 3D object and add a plane on it. Double click on plane, change its view to the top angle, and I will quickly resize this plane as the size of the virtual button. Perfect. Now I'll add an image on it. For that, I already made one image, which is this show data image. I'll drag and drop this image into the Unity file, and I'll drag and drop this image to the plane. Okay, its orientation is not proper. I'll change this orientation to 180 degree, and we are done. So we are done with adding all the components for our project, and then now the last step remaining is to add the logic to our project, like adding the script to our project. And for that, I already prepared one script. Let me show you that script. So here's the script. I'll drag and drop into the Unity folder, and here is the click.cs, like the C# script. Don't worry, I'll be explaining you the logic I have added in this particular script. Okay, so I'll double click on the script to open it up, and here is that script. So first of all the necessary libraries are declared here, pretty common. And after that, here we have declared two different variables. One is for temperature, one is for humidity, and one public variable for adding the virtual button. Pretty common. Okay, after that, in the void start function, we are assigning that input field temperature and input field humidity component to the variable temperature and humidity. Now these variables are responsible for adding the data or writing the text to that particular input field. Okay, after that, what we are doing is we are assigning one function called as on button pressed. Okay, so as soon as the virtual button is pressed, this function will be called. Now let's just see what happens when this button is pressed. So as soon as the button is pressed, we are inside this function, and here we are calling two other function, which is get data temp and get data humidity, which are obviously responsible for getting the temperature and humidity data. Okay, after that, using this debug.log function, we are just printing click inside the debug window. Okay, so that's a pretty, like, this is just for debug purpose. You can comment it. It's of no use inside like building the logic. Okay, so after that, let's just try to understand these two functions. Okay, so as soon as this get data temperature function is called, we are starting the coroutine called as get data coroutine 1, and when we are calling the humidity data, we are calling the coroutine which is get data coroutine. Okay, let's just understand these two functions. So inside the get data coroutine 1, which is responsible for the temperature data, we are just requesting one link, which is this link. Okay, this is again a Blynk API, but it's different than the previous episodes. So in the previous episodes, what we are doing is we are requesting one link to write the data to the Blynk server. Okay, maybe we are turning the virtual pin v1 on, or maybe we are turning that off. Okay, but now what we want is, as soon as we request one link, we want the data back in return. Okay, so for that, this API link is responsible. So here in this Blynk API link, you just need to provide the authentication token of your Blynk project, and you need to provide the virtual pin number whose data you want to read. Okay, if I show you my smartphone, then I already prepared one Blynk project of monitoring the temperature and humidity data using the DHT11 sensor. Okay, let me just start the screen recording. So here is that Blynk project. As you can see, the temperature data now is showing as 26 and humidity data is now showing as 39. Okay, so this data I'm getting from the DHT11 sensor using my ESP32 board. You can use the Node MCU board as well. I'll attach the video link in the description, using which you'll be able to easily make this particular project. Okay, so yeah, so V0 contains the data of temperature, and V1 variable contains the data of humidity. Okay, so what I'm doing is here I'm just putting the link as V0, and with this I'll be getting the data of temperature, and here inside the second function I put the pin number as V1, and I'll be getting the data of the humidity data basically. Okay, after getting the data, we are just writing that data using temp.text command. Okay, using this command we'll be able to write that particular data inside the input field in the AR, okay, that we have prepared inside the Unity editor. Okay, similarly for humidity, we are using hum.text, which will be writing the humidity data to that humidity input field. Okay, so that's the simple code that we have written to build the logic of monitoring the sensors data using augmented reality. I'll quickly save this particular script, and after that, here inside the Unity editor, you just need to drag and drop this click script inside the image target. So I'll click here and drag and drop it to the image target, and after that, just click on the image target, and as you can see, here is the script added. Now we just need to provide the virtual button. For that, just click on the virtual button and drag and drop this virtual button to the VB on. And with this, we are done with all the steps to make the project of monitoring census data over internet in real time using augmented reality. Like, hate to press the like button right now before like watching this particular project in action. Now, before exporting this particular project into the APK file, like the Android supported file, let's just test this project right now here inside the Unity editor only. For that, I'll quickly bring this target image. So yeah, here is that target image. I'll quickly press on the play button and let's see if this works or not. Okay, it's working, but the image is too big because we haven't scaled down the main target image. So let's just do that. So click on the target image and just scale everything down to 1/1/1. Okay, now it's scaled down to its original size. Now just click on the play button. Okay, now everything is visible in the real size. Okay, everything is perfectly fine, everything is perfectly visible. Now let's just click on the show data button and let's see what happens. Okay, as you can see, the temperature value is shown as 26 and the humidity value is shown as 39, which was the same data displayed onto the smartphone using the DHT11 sensor module. Okay, so yeah, our project is perfectly working inside the Unity editor. Now the last step remaining is to export this particular whole project into the APK format, the Android supported file. For that, just click on the file, click on build setting, click on Android and click on switch platform. Okay, so the platform is successfully switched. Now you just need to click on the build button. Here, just give the name to the file. I'll name it as AR Sense. After that, just click on the save button. So now it will start preparing the APK file. So now what I'll do, as soon as it gives me the APK file, I'll directly install that file into my Android smartphone. And let's just show you this project working in action inside the Android smartphone. As you can see, as soon as I put my hand over the show data button, I'm getting the temperature and humidity reading data straight in AR in real time. So yeah, that was all about an AR with IoT project of monitoring census data using augmented reality. I hope you like this project and do let me know like what more things you want us to do in AR with IoT. Like, till this project we have planned our AR series. Now we don't have any such plans to continue this AR with IoT series unless you give us some inputs. Okay, so do let me know in the comments like what crazy idea, like what more ideas you are getting in your mind with the help of AR with IoT, and we'll definitely try to make that project just for you guys. So do drop your comments in the comment section. And that being said, I'm just ending this video here and now. Just wait for my next one and explore, learn, share with me, techiesms.